welcome to the eSIM Marathon webinar series. Good morning, good afternoon, and good evening from different time zones. Welcome. So, this time we have Aryavarta Semigyan for this eSIM Marathon webinar series today. So, welcome to Aryavart Semigyan, and we have Anushka and Ria Soni from Aryavart Semigyan. So let me talk about Aryavat Semigyan. So Aryavat Semigyan is a non-profit initiative devoted to semiconductor knowledge sharing for nation building. It embodies the spirit of Gyan, carrying forward India's tradition of collective wisdom into the world of modern technology. This organization is focused solely on documenting, preserving, and sharing semiconductor understanding, making knowledge free, accessible to empower the wider community. However, Semigyan stands as a beacon of open knowledge, ensuring that insights in semiconductors are not confined but are shared as a collective heritage to strengthen India's technological future. So, from Aryavar Semigyan, we have Anushka. So, let me talk about Anushka. So, Anushka is a full-time VLSI engineer at Monk Tech, where she is contributing to fabrication and VLSI design projects that supports India's growing semiconductor ecosystem. And so she has also done her internship from SSPL DRDO, and she has worked on different FPGA based peak detection system programs, and she has also participated in a DIRVI symposium hackathon and secured the second position there. And yeah, so she is basically the founder of this Aryavar Semi community, and she is the leading this community. Along with Anushka, we have Ria Soni, another expert who is a physical design engineer with strong expertise in open source VLSI development, and she has successfully worked on multiple ASIC projects using Skywater technology, and she has a lot of experience in working with OpenLane and different other chip related scalable chip implementations. So yeah, so welcome Anushka and Ria Soni from Aryavar Semigyan. So yeah, so over to you, Anushka.
Today we will start with LibreLane. So LibreLane is a updated version of OpenLane. We will see how to integrate that Open PDK by IHP microelectronics with the latest OpenLane version. Latest OpenLane version. So basically, LibreLane is the OpenLane 2 version, but updated one with the help of it. It is mainly working with the help of Python. So I would like to call Ria Soni so to give a basic introduction of PD and everything.
Hi, good evening, everyone. I sincerely thank Professor Sumantakar for the warm welcome and for organizing this wonderful event. And it's a pleasure to be here with you. So yeah, hi, I'm here. I'm Ria Soni from Monk 9 Tech Private Limited Company. And yeah, so thank you so much for inviting here, and thanks Anushka Tripathi. So yeah, so let's get started with our session. So first of all, why open source? Can anybody guess why open source tool in the world of Cadence and Synopsys? Can anybody just tell me why open source? Any guesses, anything that why we are using open source tools for designing our chips? So, okay. So,
For creating IP.
yes, okay, then I want basic. Why we are using open source tools in the world of Cadence and Synopsys, license-based tools, but though we are using open source in
Because in
for chip
license are
design.
totally.
It's free to use. Others are paid.
Yes, exactly. Exactly. Perfect. So yeah, first of all, it's free and accessible. So anyone can design chips without expensive tools. So that was the most beneficial for us. And it supports community collaborations. So designers and students can share and improve designs together. So yeah, everything is transparent from RTL to GDS. It's a fully verifiable, right? So it's a great for learning and prototyping. It's ideal for education and research. So yeah, we for students, for researchers. So this open source tools is very beneficial for them. We can make real chips using these tools like OpenLane and Caravelle using open source open PDKs like Skywater 130 nanometer. Okay. Yeah, this is the tool where I can show you all. So first of all, what is OpenLane? What is OpenLane? Any guesses? Have anybody heard about OpenLane, Caravelle?
Yes, ma'am.
Anywhere, anywhere. Okay. So what is OpenLane? So OpenLane is an open source ASIC design flow for turning your Verilog RTL into fabrication ready GDS layouts. So from writing RTL code to the tap out process, all things is doing OpenLane, right? So build on top of OpenLane tools like Yosis. It's inbuilt, right? Yosis, OpenRoad, Magic, NetGen, all the things are included in this. What are the key features about this OpenLane? So first is it's a fully automated digital flow from RTL to GDS. Then it uses Skywater 130 nanometer open PDK. Then it supports LPS, DRC, and STA in power analysis. Like LPS means layout versus schematic, then DRC means design rule check, STA means static timing analysis. All it supports all the things. So it's ideal for research, educations, and for tap out programs. You can use this opening flow for your chip designs, right? So what are the steps of this opening flow? From starting Yosis means from starting synthesis, writing RTL code to the GDS step out process. So from RTL synthesis, then second is floor plan, placement, clock tree synthesis, static timing analysis, routing, DRCLPS checks. These are the in physical verifications and the sign off process. There are DRC and LBS checks. And the last step is the GDS leaf file. Okay. Uh, Understood about the OpenLink, that how OpenLink works?
Yes.
Okay. Yes. See, this is the full chip flow from system specification, architectural design, functional and logical design, circuit design. The main step is the physical design. In physical design, there are the steps: partitioning of the chip, floor planning, power planning, what is placement, what is clock tree synthesis, what is routing, timing closure, and the physical verification and sign-off process, fabrication, packaging and testing, and the GDS chip finishing is the GDS file. Right? Okay. So why use open source tools for ASIC development? So open source tools, RTL to GDS is there. Then in Yosis, logic synthesis, Verilog to gate level netlist. Then OpenLane, it's a full RTL to GDS flow automation. Then Magic is used for layout editing and DRC checking. K-layout is used for GDS viewing and inspections. NetGen is used for layout versus schematic check. And OpenSTA is used for static timing analysis, right? So in OpenLane,
Hello, Ria. Just sorry to interrupt. Can you show the previous slide? What's
okay, yes.
uh-huh. So just
Okay.
I wanted to add to your thing for the marathon participants. This system design specification to circuit design will be done as a part of this marathon. Yeah, people
Hmm.
can try out the physical designing and yeah, but after the marathon, definitely one can try out and we will appreciate and our end goal would be to get the chip fabricated from the IHP IHP fabrication unit. So yeah, so we would request the participants to try it out in very enthusiastic way
Yes,
and
exactly.
yeah.
Yeah.
Yeah, so thank you. Yeah, you can
Yeah.
continue. Thanks for
Yeah.
showing this chip flow. Yeah.
Yeah. Thank you so much. So, OpenLane supports two nodes that are the open source PDK nodes are supported by Skywater and Google Foundries. So, most popular Open PDKs is digital and analog supports that was the 130 nanometer, and the second global foundries is the GF180 MCU that was the 180 nanometer, used for analog and mixed signal purposes, right? So this both PDKs are open. Yes. So first of all, uh, what is physical design? Now the main step in the VLSI is the what is physical design in VLSI. So physical design is very crucial step in our designing. So it converts RTL code to the physical layout. Synthesize RTL code into a physical layouts. That it involves all the steps from placement, from floor planning to placement, routing, timing, STA, sign off process, all the things. And the final stage is the GDS file. We need to send GDS file for the foundry for the fabrication. Okay. It ensures the design is functionally correct. All we need to check the our design that it's meets the timing or not and is manufacturable or not, right? So yes, here are the file formats in PD we are using. So first of all is the Verilog netlist synthesized file, then the liberty file .lib file, then timing and delay data, then leaf file, layout exchange format, then def file, that was the design exchange format, then GDS, it's a final layout we need to send for the fabrication. This is the final file for the GDS. Then SPF, SDC, SDF, then these all are the constraint files we need to write, right? So these are the file formats in PD. Okay. Then why cheap partitioning, first of all? So here are the chip partitioning. So we need to break our large chip into a smaller blocks, right? So these are the blocks: CPU, memory, inserted our logics, and here are the small blocks, right? So yeah, so we need to break our large chip into smaller blocks to simplify design, enable parallel works, and improves the performance and reuse the modules, right? So what is chip? Why chip partitioning is important in physical design? Then the next step is the floor planning. Without floor planning, we cannot send our design for the fabrication. So here is the main step for starting the designing, floor planning. So in floor planning, we need to define the core area where standard cells will be placed and where die size, what will be the die size. Then we need to place our macros, hard macros and soft macros are there. In soft macros, there are our standard cells, our logics, or logic gates like AND or NOT. And in the hard macros, our macros are like IPs, memories, etc. And IO pads to minimize congestion and improve routability, right? So here is the silicon wafer. Inside that there is a core. See, you can see this. Here there is a die and inside there is a core. So we need to decide core also, and we need to decide die also. So insert silicon wafer. This is the die and the core. Okay. So why floor planning is important? Now the second step is the placement stage. So yeah, automatically it's placed the standard cell while maintaining logical connectivity, legalization, ensures no overlaps, and aligns cells to placement grids, right? So here are our chips. Inside that we need to place macros and we need to place cells. Macros are both soft macros and hard macros, and here are our logic cells. Means we need to place our cells that type that no overlaps between the cells. Okay. If cells are overlaps, then our designs will be failed. Then the third step is the routing. Routing connects all placed cells by creating metal wires based on the netlist connections. These are the inside the chip. There are the metal layers. Metal layers means wires. We need to connect our layers like macros, IO pins, IO pads, then our logic cells. We need to connect all the things through the routing process, and that was the metal layers. These are the metal layers. So what it follows? So it follows the design foundries checks like spacing, width, placement to avoid errors. So ensures that every signal reaches its destination accurately and within timing limits, right? What is now the fourth step is the clock tree synthesis. Builds what is clock tree synthesis? What is clock tree synthesis? So it builds the clock distribution network from source to all flip-flops, right? So in clock tree synthesis, we need to check that our design, our timing match the uh, area or not. Means we need to check that our design match the timing or not. That's positive timing is there, negative timing is there. All the things included in the clock tree synthesis. It builds clock distribution network from source to all flip-flops. Yeah. So the last stage is using this. I have made a CNN using this open source tools. So I have made this project using open source tools. I have placed PicoAvi 32. Both are macros, and I have placed these are the IO pins. And yes, my design is verifiable. So from CNN to silicon with open source tools, I have made this. Okay. Yes. Thank you.
Yeah, thank you, Riyashoni. So it was a wonderful presentation. Uh, so now Anushka will be presenting.
Yeah.
I see.
So I will be talking about why LibreLane and OpenPDK by IHP Microelectronics. So let us start with the introduction of eSIM. So eSIM is a free and open source EDA tool for circuit design, simulation, analysis, and PCB design. So it is an integrated tool built using free, or you can say libre and open source software such as KiCad, ngSpice, GSGL, Open Modelica, very later, and much more. So, so its features are that you can draw circuits using KiCad, create a netlist, and simulate using ngSpice, and design PCB layouts and generate files using KiCad, add or edit device models and sub-circuits using the model and sub-circuit uh, builder tools. It performs mixed signal simulation. It also supports for Windows and Ubuntu. So open source silicon is reshaping how we design chips. So tools like LibreLane and OpenPDKs make ASIC development accessible. So we will be discussing about this IHP microelectronics PDK and this LibreLane tool. So together they enable end-to-end open source chip design. So So what is LibreLane? So it is a successor of OpenLane under the open road ecosystem. So just like OpenLane, it does the complete RTL to GDS flow. It is modular. You can create YAML files and .json files also. It is Python-driven architecture. It is backward compatible. That is, it is a classic mode. Its key features are that it have modular flow steps configurable via YAML. It have improved logging and multi-PDK support. So the need of OpenLane. So it with OpenLane 1, it had a monolithic TCL flow. It was hard to customize. But in LibreLane, it have some advantages like it have Python-based modular steps. It is flexible and stage control. It offers stage control, and it also offers smooth integration with IHP SG13 G2 PDK. And how we can do it, I will tell you now. So let us talk about this PDK. So it is 130 nanometer BiCMOS process from IHP Germany. So it is openly available for R&D and education. It supports analog and digital mixed signal design. It can be actually it have support for LibreLane, and how to use it, I will tell you that. So its key characteristics are the following as mentioned here. So it can be optimized for low power, high speed. It has 6 metal stack. And how to run it? So this is our command how to run the flow. So you have to run this command, uh, and here is our path to our design, and this is our config.yaml. I will show you everything on my PC. So it loads the PDK and map layers and rules. Then it does the synthesis, PNR, sign off, and it generates the output GDS2. So it's a sample file. I will tell you how to make the config.yaml. So LibreLane is modular. Uh, it provides, you can do the config YAML flow, and it and IHP SG13 G2 is a 130 nanometer open PDK. So both are open source and they both have their own advantages. So so now I will take you to the uh, real steps how to do it, how to integrate it. So actually, uh, it is for running any other PDK. Actually, LibreLane gives supports for Global Foundries PDK and 180 nanometer PDK by Global Foundries and Sky 130 nanometer. And if you want to integrate any other PDK, you want to work with any other PDK with the LibreLane, so you need to have the LibreLane version 3.0 as of now. So as you can see here, I have shown you the command next develop dot dash c LibreLane dash dash version. So it gives the output. You need this version in order to smoothly work with any other PDK apart from Sky 130 or uh, Global Foundries PDK. So for that, you have to actually, it takes lot of time to run all these commands, as you can see. see in this on the screen. So I have just put up the screenshots. You can take a look what I have done here. So I will take you to my screen now. So this is the documentation of Open PDK. So you can go through this, and as you go through this PDK directory structure, so as you go in libs.tech, you can see it have provided the support for LibreLane also. It have various config.tcl, so you can modify according to your needs also for the designs you are doing. It have and here it have all the left files, GDS files, everything is here in this directory. And now let us so how to search this LibreLane documentation. So you have to search OpenLane. So this is the OpenLane official repository. In this, you can see they have mentioned it is in maintenance mode, and they have also given the link to the updated version of OpenLane, which is LibreLane. So you can go here, and there are different ways of installing LibreLane. You can install with Docker or with just a single Python command, or there is a Nix installation also. But the preferred installation will be the Nix installation. So if you want to install with Nix-based installation, you can go here, and based on your PC, whether it is Windows or Mac OS, you can install the LibreLane based on your needs. Then let us, so this is the LibreLane documentation. So if you have already used OpenLane and want to see that how is LibreLane different from OpenLane, you can uh, go through this documentation. But so you have to clone the LibreLane, and you have to enable the Nix shell. So this is the documentation, and then you have to create the design directory. So this is my LibreLane installation. So this is the cloned LibreLane GitHub repository you can see here. So, and I have created the design directory here. So these are the various designs you can see here. This is the PWM controller, which I have made with the help of IHP Microelectronics PDK. So as you can see, this is my config.yaml. So I have specified uh, the design name and the library, standard cell library, the PDK root, and everything, all the parameters of the design is here. So this is how I have created the config.yaml, and this is the pin config file. It is based on the inputs and outputs of the PWM file. So this is my PWM design. So now how to create the PDK structure. So when you will install, so you have to create a PDK directory. So this is my PDK directory. In this, I have cloned the IHP Microelectronics PDK. So you can see here, this is the directory structure, and you have to, and wherever you are creating this folder, you have to export the path of this directory. Then only the LibreLane will detect that the PDKs are in the correct path. So as you can see here, so let us start the next shell. So it's a quite big installation process. So I will make a video and send you all. So because it will take lot of time, and we have a very short session. So I will send you a YouTube link of how to do the installation. Right now, we will just have an overview of how to use this tool. So this is how, using this command, you have to enable the next shell. So it takes time. So this is the next, our next shell have been enabled. So you can go to the My Designs directory. So, and here you can run the command. This is our command. I have manually specified the PDK here. So if you want to learn how to manually add any PDK you want to add with this tool, so for that you have to go through the uh, documentation here, as you can see here. So they have specified. So they have given here how to add any PDK you want with this tool. So you have to read this part on how to add any PDK. So you have to run this, and you can see it's complete synthesis from RTL to GDS processes taking place here. So I can show you the runs directory here. So this is our runs directory, and all the process flow have been taken place successfully here, as you can see here. So you have any questions in using this tool with the open PDK, which have been a part of this hackathon?
Yeah, I have a question regarding the LibreLane.
Yeah.
So I checked the documentation, and for system requirements is asking like i7 processor and 16 GB RAM for recommended system. So
No, actually, there is a recommended version and there is a minimum version you need for that. If you are
okay,
using the minimum version, that's all fine. Even my PC also don't have the specification as mentioned here, but
okay,
things are working fine here.
okay. So I can run it in VirtualBox, right?
Yeah, in fact, I am using Core i5 16 GB RAM, but it's working all fine here.
Okay,
Yeah. So I know it takes a lot of time to install this LibreLane along with the PDK support for the IHP microelectronics. So I will make a detailed video on this YouTube video and send you all, because it takes a lot of time. Any question?
Anushka, there is a question from Kevin. So we usually have error in that PDK path configuration.
Yeah. So you have to create a PDK directory here. As you can see here, this is the PDK's directory, and you have to export this path. You can see here, this is the path, and you have to create a directory like this. So this volar, you can see here. So LibreLane automatically downloads it. Uh, so whenever you run any design by default, it will use Sky 130 with the help of this volar. So you have to create a separate directory ihpsg13g2. So I have also worked on this flow and it was giving lot of error in the LibreLane 2.42 version I have worked on. But when I installed LibreLane 3.0, so my flow was working all right. So you try that dev version, LibreLane 3.0 dev version. So as you can see here in this presentation, so here is the LibreLane v3.00 dev 39 version. You have to use it for using any other PDK apart from Sky 130 and that Global Foundries 180 nanometer PDK. If you follow these steps, your flow will be all fine, no errors. So, which is not even downloading. So, is OpenLane version not working? Actually, uh, I have shown you the OpenLane GitHub repository right now, so that is under maintenance. I also downloaded that GitHub OpenLane directory, but it was not working fine. So you should go with LibreLane. And when you go through the IHP microelectronics PDK directory, so they have given us support for LibreLane. So as you can see, there is a specific folder for LibreLane. They have created the config file, all the TCL and mapping files and everything is here. So LibreLane will give you a very good support for using this IHP microelectronics PDK. So I prefer that you use LibreLane over the OpenLane tool. Yes. So this was from my side, and you can see also our flow was successful and all the files of the designs were successfully generated here. So
Yeah, any questions? Please feel free to ask here.
Yes, Kevin, that's perfect for GDS. Yes, so OpenLane and LibreLane both are similar, just slight differences are there.
yeah, it's a Python based. LibreLane is more based on Python than OpenLane.
Yeah, I have one question for LibreLane as well.
Yeah.
So while installing LibreLane, does Magic and K-Layout automatically get installed, or I have to download it separately?
Yeah, it gets installed with that. Magic and I think key layout support is there. Magic was not there as you can see here, the magic and key layout files all are generating here. So yes, magic and key layout both are supported with LibreLane. Yes.
So K-Layout also gets configured with the PDK's path as well when it's installation.
Yeah, yeah. For that, I would repeat again, use LibreLane version 3.0. In 2.4 version, it will give lot of errors in the flow.
Okay, thank you.
Yes.
Yes, so Tanay has asked me what is a CNN chip. So yeah, it's a convolution neural network. It's a one type of neural network inspired by the human's brain visual system. right? So it's best suited for the image based input data, and also it has some features like convolution layer, pooling layer. Then it has fully connected layers. So, and the layers work together to process and learn from data hierarchically.
Are you now confident that you can take any of your design and do the GDS flow with the help of LibreLane? Actually, it's a very easy thing. Just you have to set the PDK path properly and create the config file, config.yaml file properly, and it will run all fine. Just you have to run this single command you can see here. So you have to just run this command, this you can see this, and it will do everything from RTA to GDS, everything. So it's a very easy tool to use. As you are asking that we need to check step by step Slack area and DRC and LBS. Yes. So how to do all those things? So you have to go through this user guides by LibreLane. Everything is mentioned how you can go for DRC and LBS check. So it's a big tool. You need to explore how to do that. And Ria can tell you that how you can do the DRC and LBS.
Yes, for sign-off process, DRC, LVS checks, design rule check, that LVS means layout versus schematic check, that all you need to define in the config.yaml, right? You need to define uh, your Foundry's verification, that Foundry and yours rules are matched or not. After that, LVS step is there, layout versus schematic. Yours design and the layout nettest designs are matching or not. After that, the design will pass through the Foundry process, means the GDS file. If these are the main three steps: antenna violation, DRC checks, and LVS checks. This all three are the main three checks that we need to check before sending our GDS file for the Foundry. Okay.
Yeah. How does flow also include pad rings around a design or a pad ring generation step?
No, padding doesn't around the designs. We need to manually write our files.
Yes.
Manually, we need to write all the things like
Yeah.
pin configuration, then our SDC file, then for macros, all the things we need to write manually.
Any more questions?
An example for sequential circuit is on Git. Means, can you clear me this question? You can start with OpenLane also for basic, for learning purpose, and after that you can switch to the LibreLane.
Any beginner design you have to do, there is already a SPM design. You can see how it works. In as an example, it is already there. Yeah, it was having error in PDK. I also worked with OpenLane because the GitHub of OpenLane is under maintenance. So you can go with LibreLane as of now. Actually, I am using the latest Ubuntu. It is given here. If your PC fulfill this minimum requirement, it's all fine. And this is the recommended one, and you need Ubuntu 20.04 for at least 20.04 LibreLane. So, Sumantokar, anything more you want from our side?
Yeah, it was a wonderful presentation. There are some more doubts. Can we use VHDL?
Yeah, you can use that.
Can someone share the GitHub link where those examples are?
You can search LibreLane documentation also on
I am
Google.
sending.
Yes.
I will send you a installation video of how to install LibreLane and how to add any PDK you want with the LibreLane tool. Actually, it takes lot of time, so it will take lot of time of the meeting. So I will send you a video.
Okay, so yeah, please send us the videos. And
Yeah, today only by evening I will send you.
I would request participants to currently focus on the tasks of the marathon and try to design a circuit, simulate it first, and then they can proceed with the LibreLane and definitely have the complete RTL to GDS too. And we can then plan for a tape out from ISP fabrication unit. So
Yes.
I would like to thank Anushka and Ria for conducting this session on LibreLens. So thanks a lot, and hope to see you again sometime as a part of
Yeah,
some other
Yeah.
event of FOSSI. And yeah, thank you.
yeah,
Thank you so much for this event.
Yeah. It was a
yeah.
wonderful session. Yeah.
Yeah. Thank you.
Okay. Okay. Bye then. Thank you.